Hi everyone, just wanted to take a moment to talk a little bit about graphing absolute value functions and to talk a little bit about some of the important features of absolute value functions. So what we're going to start with is we can see here I have typed out the absolute value function. So for the record, the absolute value function that would be this, right? Absolute f of x is equal to the absolute value of x. So this is the general one. This is the parent one, and from there we're going to kind of transform. Okay. So what we're going to do to start off is you can see I have a bunch of points here, and we're going to just explore what happens when we change the value. So I'm going to leave a 0, and then b I'm going to make it 1. All right, and you can see when it's 1, it kind of starts following up, and then I'm going to make c -1. And as you can see, what has happened is it went the other direction, but it still went up, right? So it still went up. Um, Now I'll continue on with D and we'll go up to 2. All right, so we're continuing on this pattern. So what we should expect, this one's going to go up, but in the other direction. And it does. All right. So what we would expect if we did 3 would be on the other side, 3 would also, -3 would have the same result. And it does, right? It's still going up like this. So we're making this little V shape where we would kind of predict if it keeps going like this, it's going to kind of form a little V, right? And the reason behind that comes from the fact that if we look at it, right, if I plug in f of x equals, if I plug in 1, 1, it would just be 1. But if I plugged in -1, I would get the absolute value of -1, which is still just 1. So that's why we get this kind of V-shaped thing, because anything that would be happening when it's negative, you're just flipping it over and making it positive. So whereas a line, it would have continued on, on this side, it would have been like that. We're kind of flipping this part up, right? We're flipping it up. So we would predict, for example, like if I did 10, if I did -10, I would get the same thing on the other side. And that's what we ultimately see happening. So if I connect the dots, shut it off. Okay. So if I connect the dots, what you can see here is we do get that V shape if we were to continue on forever. And just to confirm that I didn't just screw something up, right? If I graph that, see, right on top of itself. Okay. So as you can see here, it's essentially just if we had flipped it up, right? Or alternatively, you could also think of it being this side flipped up, whatever, your call. But as you can kind of tell, and what we're going to do next actually relates to this, right? Where we essentially have two different functions that we just took this part of one and this part of another, and we just slapped them together. So that's essentially what has happened here. And that's going to be our next topic. But for right now, let's talk a little bit more about the absolute value function. So what do we notice about it? Well, it forms that kind of V shape. Additionally, whatever is happening on the right-hand side is happening on the left-hand side. So if I found this point up here, we would expect it to be this point. It is, right? So what is happening is we're essentially reflecting over, in this case, the y-axis. So this right here, the vertical line that goes through the point of the V, which, by the way, that right there, that's the vertex. The point where it starts to change directions, that would be the vertex. So the vertical line that goes through the vertex, this is called the axis of symmetry. Right? So this is the axis of symmetry. And anything that you do on this side, we're going to do on the opposite side. You just kind of would count over, right? If I go over 7 here, I go over 7 here, same thing. And that might not be a big deal for us right now, where everything's related to the y-axis. But later on, when we start moving it around, that's a really useful tool because it means I have to plug in less points, right? I can get away with plugging in 3. Once I know the vertex, I can do 2 on this side, and bam, I know 2 on the other side. So what else do we notice? Well, on this side, we're decreasing. And on this side, we're increasing, right? So on one side of the vertex, we're going to be decreasing. On the other side of the vertex, we're going to be increasing. All right. And we also notice that here, the vertex is a minimum. However, let's look at what happens if I start multiplying something times the absolute value function. Now, for our purposes for right now, we don't really care about this, right? I don't care about that scenario because look what happens. If I plug it in, nothing changes. And the reason nothing's changing is because I'm still taking the absolute value. So at the end of the day, it doesn't make a difference. Okay, so we're not worrying about that. We're going to be multiplying outside of the function, right? So essentially what we're going to be doing is this kind of like, a vertical compression and stretch. So let's see what happens if I multiply by, let's say, 2. And I made this one below as a reference guide. So the black line will be the parent function, right? So if I multiply by 2, what do you see? It kind of gets stretched up, right? I took it and I pulled it up. And if I put a bigger number, let's say 5, it gets closer and closer to the y-axis, okay? And, if I did like 19, see, we're way up there. I'll go back to 2. But, so when you have a number bigger than 1, right, you're going to get a vertical stretch, right? We're being stretched up. However, if I had 1/2, we kind of pulled it down. We've compressed it. We've pushed it down, right? So when you have a number between 0 and 1, a fraction, you would have a compression, okay? So that is ultimately what we've seen thus far. However, there is one thing we still need to do. What happens if I put a negative out front? So when I put a negative out front, as you can tell, essentially what has happened is I just flipped it over. So when you put the negative out front, all you're doing is you're flipping it over the x-axis in this case. Right, so in the future, you'll see that instead of flipping it over the x-axis, you'll essentially be flipping it over a line y equals whatever the y coordinate is. So right, I flipped it down when I put the negative out front. And what has happened? Well, a lot of things have changed. We still have the axis of symmetry, mind you, right? Because whatever is going on here is still happening over here. So we still have the axis of symmetry. That didn't change. The vertex did not change when I put the negative out front, okay? So the vertex and the axis of symmetry stayed the same. However, we've kind of had a couple different things have changed, right? This is now a maximum, okay? The vertex is now a maximum. And on top of that, we've now been increasing on this side, and now we're decreasing on the other side. So we've we just switch which side is increasing, which side's decreasing, and we've switched the maximum, the minimum to a maximum. Now, does it affect the rest of our stuff, right? If I still do 2, I'm still being vertically compressed. If I do, I'm sorry, I'm being vertically stretched, my mistake. And if I did 1/2, right, I'm still being compressed. I'm still pushing it towards the x-axis. So the rest of the information doesn't change. It's just that now it's flipped over. All right. So that's a quick little overview on all the information relating to absolute value functions. We will talk a little bit about how to shift them going forward. But please let me know if you have any questions. Have a great day.